Hi, my name is Ray and welcome to my channel. So this video is an updated version of LRUTrie Typeahead system design. It was published almost 2 years ago and I didn't bother to record it on a proper microphone. This question is pretty often asked in system design interviews, so it might be helpful to re-record it and add additional details and also account the feedback that you provided in the comments. So I've tried to add more to deep dive content in this video, so this video might be longer than the previous one. And so without further ado, let's get started. So let's overview the problem. Typeahead is a widely used component that you can encounter across many places. It can be Google search, Amazon store, or any other place where you want to search for certain things. When it comes to designing these components, there are a few interesting decisions we can make. Before we start any system design plan, let's have actually the plan. So I'm back to my Draw.io board. Let me just quickly set things up. So let's write our system design plan. The first step is to clarify the general requirements for the component. Second step is we want to understand the advanced functionality of the component. So the general requirements is just like high-level requirements, what you expect, what the main behaviors you expect from the component. The advanced functionality involves like how can you configure the component, what the properties that you want to set for the component, and so on. So once we have the general requirements and advanced functionality requirement, we can propose the quick mockup of the component to understand like the basic layout structure. So the next iteration, once we have the mockup ready, general and advanced functionality described, so the next step is to propose the API design. So the API design involves the property model that we expose for the external users, like for engineers or for any external developers, or for us. Once the API design ready, we also want to understand what is this internal state model. Internal state model represents like how we store things internally and what the data is stored, like what are the data structures we use for system design, and so on. So once the API and state model is configured, the next step is to understand what are the problems we can face when designing the Typeahead. One of the most common issue is the race conditioning, and I'll get back to that in the further sections. So just a quick description: race conditioning is when we try to send multiple requests from the Typeahead, and when you receive the data, you don't expect the data to be received in the order that you make a request. The next point is we want to understand how can we optimize the performance. We also want to consider the security concerns. And of course, it's the accessibility. So this is our general plan, and I suggest that we start executing this plan, and of course we start with the general requirements. And this will be our first step. So let me quickly decrease the font and let's go. So what are the general requirements for the Typeahead component? So basically, it's just some high-level things that we expect from the component. For instance, widget should provide autocomplete results based on the user input. So the second thing is the widget shouldn't be restricted to a certain data type. So it's kind of should be able to work with any generic data models. So the first thing that we want to add is that the widget should efficiently request the data and cache the result. So in the footage section, you will see that the caching is actually pretty advanced, and like in 90% of the scenarios, you might not need the caching. But the efficient request model, the configuration of how we request the data, is pretty important. So what else can we add? Yeah, so the widget should also work both with the asynchronous data and with the static data. All right, so we typed our general requirements for the widget. So what about the advanced functionality? So in terms of advanced functionality, there are a few pretty interesting decisions that we can take. Depending on the use case and the architecture of the widget, this can be drastically different. So let's overview like different Typeahead architecture based on the use case. The naming convention that I'm using is not mine, so actually I just made it up, so it's not like the standard, so you can call it whatever you want. So first of all, we need to understand what the use case we are trying to solve. And for that, so let's list our possible architecture types of the Typeahead. So the first type of the architecture that we have is the stateless. So the stateless component architecture is the most common across across many design systems or across many variant of component designs. And it's pretty straightforward and very well-known model. And in most of the cases, most likely you want to use the stateless architecture, and we'll get back to that soon. So another variant of the Typeahead is the stateful, or you can also call it static. So the stateful or static is the opposite of the stateless, of course, but it's a different. So the main difference is that the stateless component architecture doesn't hold any state internally. So the component accepts the props, renders the data, and that's it. So it's pretty it's just the UI. So when it comes to stateful architecture, there is a main difference. The component controls the state, so it means that it has some internal structure that keeps the things running, and it doesn't request any server, so it can work as a standalone model. And there are use cases that you want to solve with this behavior. So another variant is the hybrid. Hybrid is the most complex architecture, and we'll get back to that soon. So let's start understanding the pros and cons of each architecture type. So we probably can start first with the understanding the stateless architecture. So because it takes time to type things, I prefer just to copy over a few things for the sake of time. So the stateless architecture, the pros, it's a pure component. It doesn't hold any internal state, and it doesn't require any complex logic to configure. For instance, we can consider configuring caching, TTL, but it's all out of scope for a stateless architecture. So this is the most generic style architecture. You can build any component using this style, and it can be integrated in many systems easily because the controller of this component is located externally. So this means that the system controls the component. So also, these are the pros. The cons is, of course, that it depends on the external controller to display the data. This means that we're expected to implement the way how we handle the data and passing it inside a component. So this style of architecture is most useful in the most cases, especially with the server data driven architecture. So we'll keep this as the main option. So the next one is the stateful or static. So the stateful architecture expects that you will hold the internal state of the items that you will search. So for instance, you have the state of vocabulary that you don't, for instance, you have a database that not often changing and it's not really large. So you can, in theory, you can place it, you can load it either asynchronously and set the state to the component. This can be like some library typeahead search, or it can be contact list. So for the things that don't change often and don't require like often sync with the server, the static or like stateful typeahead has many advantages in this scenario. So let's place the pros and cons. So the pros of this architecture. Oh, that's not it. Give me a sec. So the pros is that all static data is controlled by typeahead. So there are like no external control implementation required. We just set the data to this component, and it can work with this data. So the next thing is that it can offer the best searching speed. So it means that the implementation is basically depends on us. We can choose the internal state structure wisely and use the most efficient data structure for our use case to offer the best static speed search. It also has the pretty simple configuration comparing to for instance, the hybrids, because it doesn't require any caching, TTL, or something. It's all out of scope here. The main con, of course, is that it can work with a limited data size. So not all application can use that. And especially if you have a large data set of the millions of strings or the values, of course, it's not the scale that we want to handle on the UI side, because it easily blocks the UI thread. So you want to use the static architecture type when you have the static vocabulary that doesn't change often. As I said, contact book, library, catalog. So all the things that doesn't require like often syncs with the server. Also, if you have the limited size of items. So let's move these things here and connect that one here. So the last one, which is the hybrid. And as I said, in most of the cases, you don't need the hybrid architecture. So what is the hybrid? Hybrid is the most complex variant, of course. So this typeahead combines static and the stateless approaches. So it's populated dynamically by external controller, and also the typeahead can hold the result inside internal state and use it to not to request the server and just reuse the data that's already fetched. For instance, it can be done in the catalog-based data. So you can preload the vocabulary for certain items inside a catalog, and then search internally because you fetch the data from the catalog, and then you can do the search on the static data. So it requires you to implement a proper cache management strategy, invalidation of the search results, and sync with the server. In most cases, you don't need to introduce this level of complexity in your system. But on the other hand, there are use cases where you can benefit from that. So one of the pretty common use case how it can help the legacy system. For instance, you have the old legacy API that was developed like in the 90s, and you can't really change this API, and you basically can't touch the server code, and you can't build any other API to improve the speed of the things. So in this scenario, to integrate with the older legacy system, you can build pretty smart typeahead that loads the time, loads the things, cache the things, and then allows the user to search for this data. So this is one of the scenarios. So I saw the usage of this thing in old banking system or old medical infrastructure. It's pretty complex to maintain this thing. It's pretty expensive to develop such typeaheads, and many things can break. But yes, there are advantages that sometimes you can use this approach. So, but as I said, you don't really want to use this style of architecture in most of the applications. So this was a pretty long overview, but let's just quickly summarize the things. Stateless Typeahead is like the most applicable variant. So in 90% of the scenarios, you want to use stateless. It's simple to design and it's simple to work with. Use it when you expect it to integrate components in multiple places. You build in the design system that you provide for other engineers and so on. So the static variant of the architecture is when you have this large static collection that you want to search, you can load this collection single time or for like some period of time. And as I said, this is the contact links, book library, or some other limited data sets. So it provides the best search speed because everything is searched locally. It doesn't require you to have a run to the server and wait for the API request. So it can reduce significantly the number of network requests, which is pretty good for the static offline apps. And it's also pretty often used in some like native-like applications. So the hybrid model, in most cases, you don't need it. It's helpful to work with, like with a slow legacy API, but it's very rare and specific use case. So for educational purposes, in this system design, we're going to try to design 3 of them. So we'll combine the Typeahead and try to include all the details in one system design. In real life, you want to choose one. All right, so this was pretty long overview of the things. And I think now we're ready to jump into the advanced functionality of the component. Incorporating the details that we learn right now from the architecture type. So let me copy the things over, and this is our advanced functionality. So what is the advanced functionality? First of all, it's the configuration flexibility. So when it comes to configuration flexibility, think about the items that you probably want to allow to configure. So if we're speaking about the hybrid Typeahead, then of course we should have cache-TTL. Then we also want to provide the cache size. We want to provide max results property, and we also want to think about like custom item representation template. So what's that? We want to provide a generic way to provide the way for the developers to build representation of the templates. For instance, you don't want to default to some HTML template, so the developers can decide how they want to represent the search item that they have. So this is the config flexibility. So the next thing that we also want to think about is the customization. So in terms of customization, there are a few things that we can add. Probably want to expose CSS API to allow developers to customize the CSS classes that and give unique look to our Typeahead, especially if we build some generic solution. From the security standpoint, we can think about like how can we help to filter the content. So time to time, we want to allow. So there are 2 things here. First is content filtration. The second one is the DOM encapsulation. So in certain systems, you don't want to allow any external code to modify your Typeahead. For instance, the user can install the plugin that can access, in theory, the DOM API. And in this sense, this malicious plugin can modify the DOM and try to achieve some data stealing or something else. So we want to think about like how can we mitigate the risk of modifying the DOM. So this is I never mentioned this thing, but for some application is pretty important. So the next thing is accessibility. We want to make sure that our widget is accessible on various devices and screen readers. All right, from the performance standpoint, so widget should be network efficient. We need to make sure that the widget has minimal blueprint size, and it can work with a large amount of sync and async data. So this is the advanced requirements for our component, and let me beautify things a bit. So what is the next step? The next step is just to understand how the things would look like on a mockup. So this step is optional, and I just use it for educational purposes to show what the Typeahead is. So usually the Typeahead has the following structure, and let me also copy things over here. So we have the Typeahead input where we input our data, and of course we have the search list. And inside the search list, we have the search item. So when we say the item representation customization, we're thinking about Typeahead search item. Of course, we want to provide the way how can we customize that. So I don't want to spend a lot of time on that. So this is pretty simple mockup that can help us understand what to expect, what we're actually designing. So the next step in our plan, let's look it up. So it's the API design. So in terms of the API design, I'd like to split the properties according to the type of the architecture. So for the static and stateless, we want to have the following model. So the first property that we want to provide is max results. So this property controls how many items to be displayed when we query for the search. So the next property is mean query size. So mean query size is useful property. It's like how many symbols user required to type before we can output any search data. So the next useful property is a template. So the template represents the usual template of the search item. So it can be the custom React component, or it can also be the HTML template. Since we are framework agnostic, so we will use the kind of the HTML template. Defines HTML template. And the next property is some event handlers. So the first that comes in mind is the onItem update. So onItem update allows us to lazily update the item of the Typeahead. So we want to optimize the performance of the things. And instead of rendering the whole component, we can provide a smart function that gives us the template that we need to update and the new data. And then the developer can define how they update this item. So we say it controls how to update the HTML element. So the fifth property is what happens when we do on query. So on static and state. So when it comes to the stateless on query is a required property because we're expected to be controlled by external system. So this on query can call some static search, or it can also call the async search. So this defines logic of the search. And the next callback that we want to provide is the onItem select. So what happens when you select an item? So what are our other properties that we probably want to provide? So the next property is related to the hybrid architecture. So it's the cache TTL, how long the cache entry lives. And the next one is the cache size. So how many entries we want to store in the cache. So given all of that, we can easily kind of define the structure of these things in the like TypeScript-like model. So I copy this over and also paste that. So this is just the TypeScript typing that we can provide just to understand what's the kind of the model. So as you can see, mostly it repeats itself, but in a template, what we want to do is we provide in the datum, the new piece of data that we want to set for HTML item, and we want to also provide a template, which is the HTML element. So what happens? Oops, actually made a mistake here. So we provide the datum and return the HTML template. So on item update provides us the new data and the older template. And we want to mutate this template and return the new template to set. So the onQuery, it just gives us the query and also the page size. The one property that I forgot is the page size when it comes to the hybrid Typeahead. So on item select gives us the item that we selected, and we can provide the custom callback, what happens when we select the data. So this is the API design overview. The next thing is we want to understand what is the state design for each model type of architecture. So, and to be honest, it's going to be pretty simple for stateless architecture. So when it comes to state design, for a stateless architecture, you can guess there is no state. So we don't hold any state, and we don't need to design the API for that. Or if it comes when it comes to stateful and the hybrid approaches, so there are options that we consider. So, and the first thing is we need to understand the data structure that can provide us with optimal way how can we search the things and the most performant one. So, and in Typeahead designs, you can choose many types of the data structures, but the most useful one when it comes to Typeahead is the trie. So, and I'll give you the overview of the trie just in a second. So, and the hybrid is a bit more complex. When it comes to the hybrid, then we can use the LRUTrie, which behaves like the least recently used cache, but it's using the trie as the main data structure. So I suggest that we'll give a quick overview of how the trie works, and let's switch to the slides. So let's give a quick overview of the trie. The trie is a tree-based data structure. It's also known as the prefix tree. It allows us to efficiently search by using the prefix of the word, and it makes trie especially useful, especially when we developing the Typeahead. So let's try to understand how it works. I have the basic vocabulary, which contains only 5 words, and I want to insert them into my trie in order to query them later. So what happens? Let's try to insert the car as the first word. So the root of the trie doesn't contain any data. So it just it's like initial entry of the tree. So if we want to add the car to the tree, we need to create we check the first symbol of the word car, which is C, and we create the respected node with the symbol C, and then we go to the A, we create additional leaf node containing the symbol A, and then we create the last node, which contains the symbol R. So we inserted the word car into the tree. As you can see, we created in total 3 nodes. So the next step is to add the carry. So if we try to add the carry, so we are going to reuse the first 3 nodes that were created previously when we inserted the car. So because first we access the C, then we access the A, then we access the R, and then we create R and Y as a nodes. So the next is we add in the word card and the case, and yeah, we going to reuse C and A as the nodes, and then insert the case by creating the node corresponding nodes S and E. And for the card, we just create one node, which is T. And then let's insert the Jane to this tree. Because we don't have the J as the initial entry, we have to create each node respectively for each symbol. So as you can see, we built the trie tree, and let's try just querying the data in this tree. So if we try to query CA, you will immediately see that overall we should get 3 results, which is carry, cart, and case. So how do we get here? First, we access the first symbol of the word, which is C. Then we go down the tree, and then the next node is A. And from this point, we already know that all the descendants of the A are results of our search operation. So we just basically take all the children nodes and get the values from the tree. So it took us it basically took us 2 symbols to understand if we have any results in a tree or not. If we look at the complexity of this data structure, we can easily understand that searching takes big of the W, where the W is the length of the word. So at max, it will take, for instance, if your word is 5 symbols, it will take 5 symbols to find if there is a word in a tree. In terms of space complexity, it's basically a big old one. If we try to insert into the tree, then you will see that it also takes the length for the word to insert. We need as much node as we have the number of symbols inside our string. But in terms of the space, there is one caveat. The longer your alphabet, the more letters you have in your alphabet, the more space the trie will take. In this case, it takes number of words multiplied by the number of letters in your alphabet. So this was a really quick overview of the trie, and there are many ways how you can optimize this space consumption of the trie, but it goes really beyond the front-end system design. So I hope this overview was useful, and we are going to use the trie as a data structure for the stateful and the hybrid Typeaheads. And let's go back to the draw.io board. So we are back to the draw.io board, and so we covered the trie data structure that can be used for the stateful design, and for the hybrid, we reuse the same trie data structure, but we kind of use a more advanced variant of that. So the LRU data structure allows us to set the number of entries that the trie can hold, and also it allows us to remove the entries when we exceed the cache size that are least recently used. So this is usually you are not expected to implement this data structure and explain internally how it works. But knowing that there is such a data structure, and which you can use from the library, there are multiple libraries outside of the internet that you can use. So it can help you to tackle your use case. So the next step is the data flow diagram. So the purpose of the data flow diagram is to understand how the data will flow in our application based on the Typeahead design. It will also help us to understand and spot the complexities that we may face based on the architecture type we choose. So it may sound obvious, but you will see that even this high-level schema can spot some disadvantages of certain architecture decisions. So first, let's understand the stateless architecture. The stateless is the most concise, is straightforward. So you have the application passing the props to Typeahead. The Typeahead renders the data, and when you query, you request a server API or a static handler that is controlled by the application. Once the static handler is executed, the data flows back to the application, and then the data is updated. So this is the stateless architecture. So comparing to the static, which is here, the main difference is that we initiate the vocabulary, and instead of, when you type the search query, instead of having external request or the data will go into the internal state. And once we pass the internal state, instead of going back to the application and then to the Typeahead, so the data flows back to the Typeahead. So this is the main difference between the stateless and the static. So this on a stateless, everything is handled by the application. In static, everything is handled by Typeahead. When we talk about the hybrid approach, here where you can see easily spot the complexities. So here in application, the data goes through the application to the Typeahead, then it goes to the search input. Then we may hit internal state, or depending on the circumstances. If we hit the internal state, then the data flows back to the Typeahead without going to the app. If we hit the server external API, then the data goes to the application. Application updates the data and reinitializes the vocabulary for the Typeahead. So you can easily spot how this type of architecture kind of mixed up, and you will not go with this approach unless you really have to. So that was the data flow. Remember, this step is more like an optional, just to understand the main differences between three types of the architecture. So yeah. So as a next step, let's handle the race conditioning. So let's talk about race conditioning handling. So suppose that you're trying to make multiple requests to the Typeahead. So you type your query inside, and after some time you change your mind, type again, and then type again. So most of the cases will be handled by the debouncing functionality. So we don't send the request until some timeout passed. So what if we have the case where the API is pretty slow and the debouncing timeout is not enough not to send the request? So what happens is, so we send in the first request, for example, it's the car. Then we send the second request, which is Carrie. And then we send the third request, which is cat. So all requests are sent, and we expect to get response for each of them. So what's the expectation when we get the data back? So because we work with a synchronous model, we can guarantee that the requests that have been sent to the server will come back in order that we send them. So if we so we can just imagine what happens here. So first we can receive the third request, then we receive the first request, and then the second. So the user will not expect to see the results of the carry request. So this is called race conditioning in Typeahead. And the way how can we resolve that is, ideally, we want to cancel this request 1 and request 2 if request 3 was made. So this is done through the abort controller functionality. So the abort controller is the default web API that allows us to cancel the request 1 and request 2 and have only one request free. So this is a part of the network efficiency that we declare when we start designing the things. So I leave the link to the abort controller documentation in the description. So, but now let's get back to the Trie schema. So we are back to the Trie board, and I've added the details of the race condition handling on the board that we discussed on the slides. So yeah, basically most of the design now is done. We understand how we want to implement the Trie. How we want to implement the widget. We discussed the three types of the architecture. So the next things is like performance optimization, security, and accessibility. So you probably already know what we are going to discuss in the performance optimization. So, but it's always good to repeat the things. So when it comes to the performance optimization, there are three main pillars that we work on. So the first one is the network. The second one is the rendering. And the last one is JavaScript. We'll start with the network optimization, and let's see what can we optimize here. So the first thing that comes in mind is the caching. So the caching is, first of all, how the caching works is for the hybrid, we want to use our own caching model because we expect kind of to cache the things, but there are like multiple layers here that we can introduce. So the first one is the client cache. So the client cache, it's something that we control. That's the policy that we built for, especially for the hybrid variant. So we don't really need this for the stateless and for the static approach, but for the hybrid, we can consider using the client cache. So the second step is we have the browser cache. So the browser cache is actually heavily relies on the configuration of the server header. So we need to set appropriate caching policy on the server to enable the browser cache. So the browser cache will always work even for the stateless approach when we have the external server API that we call, and it doesn't live inside the widget itself. So, but it's always good to mention that we want to consider the proper caching strategy for on the header level to allow browser to cache the things. So another thing is the server cache. So server cache is so for instance you have a costly search search result that requires some heavy CPU processing on the server. So this way you need to make sure that the server caches the things on their side too. So of course there is a kind of a challenge to manage all this free caching strategy. So but based on the use case, you need to decide whenever you want to use just the client cache or you want to combine the server cache with the client cache. So the next thing is how can we optimize the network performance is actually to make less network requests. And of course I'm talking about debalancing. So debalancing allows us to not making any additional requests while we type the query. So it's kind of pretty low cost optimization that gives great results in terms of the performance. So the next thing is the package size. So in terms of the package size, we want to make sure that we minimize heavy dependencies. And I'm talking about the NPM packages. You need to make sure that you monitor the dependencies of your package and don't introduce anything that takes like 200 kilobytes, for instance. So given that right now, most of the bundlers are able to split the things into the small modules and everything can be loaded via HTTP2. So you need to make sure that you don't load the large package just for using one function. And we also want to minimize CSS blueprint. So based on your design system, your CSS can be pretty heavy, but make sure that you don't really import the whole bootstrap thing. Most of the boundaries are able to kind of split the CSS that you don't need and include all the things only you need. But anyway, it's better to manage that only in a developer level. So in order to not introduce these things in the first place. So another thing how we can optimize the network is pretty obvious, is that the storage. So we can store the things, we actually must store the things on the CDN and make sure that assets are compressed. So there are multiple compression strategy. The most popular one is the xzip and broadly. Or Brodel. I always make a mistake in this word. So based on your CDN configuration, you could consider using one of them. So the next step is the rendering. So when it comes to rendering, there are things that we can optimize. The first one is the user experience. So it's not really rendering optimization. It's more about optimizing how the user interacts with the component. So first of all, we need to make sure that we use the placeholders and don't show any empty screen. So if the user has the visual feedback, then the loading time kind of feels less impactful in terms of on the worst side of the user experience. So, yep. What is the next thing? It's the reduce. So we want to make sure that we want to reduce the DOM writes. When we work with the libraries like React, Vue, or Angular, we don't really think about the how we work with the DOM. But in many cases, when you develop the applications, you don't really need any framework. So, for instance, if you have the custom use case, you don't want to use any library, then you need to think about this DOM writes. So this DOM writes can be optimized by, first of all, updating. So lazily. So by updating DOM lazily. So it's the property that we provided on item update that allows us to set the property of the particular HTML element instead of re-rendering the whole thing. So if you're using, if for instance, you want to output more than 100 elements inside in your search typeahead, which probably will be the bad practice, but you still want to do that, then you need to consider use the virtualization. So virtualization allows us to use the constant number of DOM nodes rendered on the screen and lazily update them, so it will not impact the performance of the DOM, especially on the lower end of the devices. So, and I'm not speaking about widget to work on the mobile devices, because the Typeahead itself is just one component. So it's unlikely that we will be able to impact the whole application with our DOM updates. But make sure that you don't introduce that, because if you want to render 1000 elements in the Typeahead, this is either the bad design, either a use case, and you need to think about the performance impact when you do that. So what else? There else is the CSS. I mentioned it in all my videos that you need to have the efficient class names. In the comments I see that it's pretty obvious what I tell, but all the time I see that developers using pretty kind of not flattened structure of the class names, and they don't really estimate the impact of these things on the large scale of the thing when you build a large scale app. So when you build just one Typeahead, of course the impact is minimal, but if you build the large app that has thousands of the class names, and it really impacts the CSS, the DOM tree building performance. if you consider doing any animations, make sure that you use the CSS for that, because the CSS animation is the optimized one on the GPU. So instead of having CPU rendering the pixels, you have the GPU, and GPU is much faster than CPU in this process because it's just rendering the pixels. And make sure that you avoid the reflows. So reflow is the process of DOM rebuilding, and you want to make sure that when you do the CSS changes, you don't trigger the reflow. Some properties of the DOM and trigger the reflow. So if you want to make sure that you don't trigger that, you can either use the DevTools to see the impact of your animation, or you can check on the internet what are the properties that trigger the reflows. So on the JavaScript side, there are a few things that can be done. First of all, we want to stick with the stateless design and use server to do expensive search. So remember, any things that we're processing on the UI blocks the UI thread. There are other ways how can we also process the things on the client without impacting the UI thread. So, but it's probably might be overhead for the Typeahead to use the web workers. But let's also consider that because it's in some use cases that might be useful. So we also want to say that we want to avoid doing sync jobs because they block the UI thread. So, and if we consider to filter the large set of data on the client, we want to consider using web workers. So that's it on optimization side. I guess we can jump to another topic, which is the security. All right, so what about the security? Multiple things can be considered here. The first one, let me try, editing the text. First one, we want to make sure that we can encapsulate DOM. So when I talk about DOM encapsulation, I mean that we don't want to expose the DOM to be manipulated by any other like external libraries or external code. So the attacker, for instance, can modify the DOM and our component to steal the data or to make user clicking on certain elements to achieve some behavior, for instance, malicious links or something else. So how can we encapsulate the DOM? So the way how you can do that is to use the shadow DOM. So web components becoming a part of the industry standard, and it's still taking time for them to conquer the world, but I think like it's a future. The browser already use web components for internal components, and I think using the web components, so the web components will be widely adopted. It may take like 5 years maybe, but we already can use them, and many browsers already support that. So you don't really need to worry about the support. So we want to limit access to the DOM using the web components. So what web components do is just they help us to encapsulate things inside the shadow DOM, and the shadow DOM is not accessible by any external script except yours, which is pretty good. And we also want to expose only like limited customization, so that may not through the class API. That will not allow attacker to modify our DOM content and try to kind of steal any data or add the malicious content to the DOM. So what else can we provide? So if we build a generic solution we can think that server might not filter the data that we expose. This, for instance, you have the server that you don't really trust in terms of it can be third-party server, and you want to provide a way just to make sure that you can filter the content that goes for the server without building another proxy layer. So for this case, we can provide the filter function. So this filter function allows us to, for instance, try to reduce, filter the external scripts, or it can filter the content that we don't want to expose. For instance, you're building the system for children, and you may use some untrusted server for that. So I know the use case is pretty rare, but if you try building a very generic solution, this can be useful. But sometimes, of course, it's overkill. So the last step is the accessibility. The accessibility is a very interesting topic, and you can actually talk 1 hour about that. But usually you don't have much time to cover all the concepts of the accessibility. So, but let's try to kind of not list the main points that we want to do with that. So, first one is make sure that all items are tappable. So this means that you can go for the items with the keyboard, and you also may want to provide the shortcuts for your Typeahead. So usually shortcuts are set on the application level. So if you can provide the configuration for shortcut on the component level, then it might be also useful in some cases. So make sure that you also use scalable units. So when I say scalable units, I'm talking about RAM units. So if the user has custom browser setting, for instance, zoom setting, then the scalable units will help to adapt to that, and they will scale your font, they will scale your the sizes of the component according to this. If you set it in pixels, then pixels will not scale by default. That's why RAM units are useful. There are multiple units that were introduced recently with the new CSS spec, but I'm not mentioning that yet because the adoption is still pretty low. That's why, maybe it's too early to mention them. So the next step is you need to make sure that you use the accessible tags. So use the right HTML. So HTML by default is already accessible. So you just need to make sure that you use right things. So for instance, input to hold the value. So you don't want to hold the value of your Typeahead, of your Typeahead search inside the internal state on JavaScript level. You also want to indicate the value that you set on the DOM level. So for that, you can create some maybe hidden input that will hold this value. So when the screen reader tries to read your Typeahead, it will see the value that you enter inside instead of reading the bare div. So div should be used as a last thing to structure your content and not to describe your content. What else can be done? So the shortcuts, arrow keys, yes, this was mentioned. And make sure that you control the focus. So the focus control is the technique when you open some absolute position window. This is exactly the Typeahead case. You have an input and then you try to type something, and then you open a small absolutely positioned window, and you need to make sure that you control the focus inside this absolute window, because by default the focus will not be switched to this absolutely positioned window. So you want to set up a script that maintains kind of the order of the focus. So if you tap through the items on the Typeahead window, you want to make sure that once you reach the end of the list, you're switching the focus to the next available input on the screen. So this is called focus control, and you can Google it. It's a very well-known technique. So that's it. This was pretty long video. I hope the details that I added to this video are useful. Please consider subscribing to the channel. This is the best support that you can give me. So all content on the channel is always free. So I'm not getting any money from that. So, and I'm just doing that because I find the joy helping the people. So please consider subscribing, ringing the bell, and also comment on the video. And I'm looking forward to your technical comments. Even if you if you see that I missed something, please tell it. So this is Ray, and I hope I will see you in the next videos. Bye.